C# History. This is part 3 of C# History. C# 10.0 was launched in November 2021 with Visual Studio 2022 and .NET 6.0. Some important features of C# 10.0 are discussed in the next slides. In C#, record structs are a value-type version of records. It was introduced in C# 10. They combine the immutability and value-based equality of record types with the performance characteristics of structs. In C# 10 and later, structure types, structs, received several improvements that make them more flexible, consistent, and easier to use. These enhancements are designed to reduce boilerplate code and align structs more closely with class and record behaviors. Interpolated string handlers in C# are a powerful feature introduced in C# 10, with .NET 6, that allows you to customize how interpolated strings are handled, especially to improve performance by avoiding unnecessary string allocations. They are particularly useful in scenarios like logging, where you might not want to construct a string unless it's actually going to be used, e.g., when a log level is enabled. In C#, global using directives are a feature introduced in C# 10, with .NET 6, that allow you to define using statements once for the entire project, so you don't need to repeat them in every file. Why use global using directives? Reduce redundancy in files, simplify and declutter your code, are especially useful for commonly used namespaces like system, link, etc. In C# 10, with .NET 6, file-scoped namespace declarations were introduced as a more concise way to declare namespaces in files. Extended property patterns in C#, introduced in C# 10, enhance pattern matching capabilities by allowing nested property patterns to be accessed more succinctly. In earlier versions of C#, when matching nested properties, you had to explicitly repeat the object structure. Extended property patterns simplify this by reusing the object context. In C#, lambda expressions can have a natural type, which means that the compiler can infer the delegate type based on the context in which the lambda is used. This is particularly useful when the lambda is assigned to a variable, passed as a method argument, or used in LINQ queries. It was introduced in C# 10.0. In C#, lambda expressions can explicitly declare a return type, especially when the compiler cannot infer the return type unambiguously. This typically happens with anonymous function expressions using the delegate keyword, or when using explicitly typed lambdas in C# 10+ with return type annotations. In C# 10, you cannot apply attributes to lambda expressions directly. Prior to C# 12, attributes could only be applied to method declarations, not to lambda expressions, even though lambdas compile to hidden method-like structures. The compiler simply didn't support attaching metadata, via attributes, directly to lambda syntax. In C# 10, a new feature was introduced that allows const strings to be initialized using string interpolation, as long as all interpolated values are also constants. In C# 10, definite assignment and nullable reference type analysis have been improved, especially in complex code paths, like when using switch, try, catch, or conditional logic. C# 11.0 was launched in November 2022 with Visual Studio 2022 and .NET 7.0. Some important features of C# 11.0 are discussed in the next slides. Raw string literals in C# 11 allow you to define multi-line strings without needing escape sequences or special formatting. They're especially useful for embedding JSON, XML, or code with lots of quotes or backslashes. Generic math support was introduced in C# 11, .NET 7, enabling you to write mathematical algorithms using generics. This means you can perform operations like plus, asterisk, comparisons, etc., on generic types, as long as they implement the appropriate interfaces. Generic attributes were introduced in C# 11 and allow attributes to take generic type parameters, just like classes and methods. Before C#11, attribute classes could not be generic. You had to pass type values as constructor arguments using typeof. Now you can write cleaner, type-safe attribute declarations using generics. UTF-8 string literals were introduced in C#11 to let you directly define UTF-8 encoded strings as read-only span less than byte greater than using a U8 suffix. Why use UTF-8 string literals? More efficient string handling for I/O, networking, or interop. Avoids costly string-to-byte conversions at runtime. Better performance for working with binary, text protocols. In C#11, you can now use new lines inside string interpolation expressions. This means you can format long or complex expressions over multiple lines inside an interpolated string, improving readability. List patterns were introduced in C#11. They let you match elements of a collection or array by position and content using pattern matching. File local types were introduced in C#11. They allow you to limit the visibility of a type to the current file only, even if it's declared at the top level. Required members were introduced in C#11. They force the caller to initialize certain properties or fields when creating an object, either via object initializer or constructor. Why use required? Prevent accidental omission of critical data. Avoid boilerplate constructors. Useful for data models, records, DTOs. Auto-default structs were introduced in C#11. They allow structs with required fields or properties to still be created using the default constructor, without a compiler error. In C#10 and earlier, if a struct had a parameterless constructor and required members, using default would cause a compile time error unless all members were initialized. This feature, introduced in C#11, allows you to use span less than char greater than or read-only span less than char greater than in pattern matching against constant strings directly in a switch or as expression. Extended nameof scope is a feature introduced in C#11. It allows you to use the nameof operator with parameters, type parameters, and local variables before they're declared, as long as they're in the same scope. Before C#11, you had to declare variables before using nameof with them. Now, you can write cleaner code like validation messages, attributes, or logging without rearranging declarations. Numeric int PTR support was introduced in C#11 and .NET 7. It allows int PTR and uint PTR to behave like numeric types, meaning you can now use them with arithmetic operations, plus, asterisk, comparisons, generic math, I number less than t greater than interface. It makes pointer math easier and safer. These are low-level features introduced in C#11 that improve performance and safety when working with references to memory, especially on the stack. A ref field allows a struct to store a reference to a variable, not just a value. Warning waves are a way Microsoft introduces new compiler warnings in a controlled, versioned manner, so developers aren't overwhelmed when updating projects. Warning Wave 7 was introduced with C#11, .NET 7 and includes new compiler warnings that highlight potential bugs or bad practices. Inferred tuple element names is a feature introduced in C#7.1 that allows the compiler to automatically use variable names as tuple element names when creating a tuple. No need to explicitly name them. C#12.0 was launched in November 2023 with Visual Studio 2022 and .NET 8.0. Some important features of C#12.0 are discussed in the next slides. Primary constructors are a new feature introduced in C#12, allowing you to declare constructor parameters directly in the class, or struct, declaration itself. This simplifies code and is especially useful for data-centric types like records or DTOs. Collection expressions are a new feature introduced in C#12 that make it easier and more concise to create and manipulate collections, like arrays, lists, etc., using a syntax similar to array initializers. Inline arrays are a new low-level feature introduced in C# 12 that allows defining fixed-size inline arrays using ref structs. These arrays are useful for performance-critical scenarios, such as game engines or low-level data processing, where you want to avoid heap allocations and keep data tightly packed in memory. Optional parameters in lambda expressions were introduced in C# 12, allowing you to define default parameter values directly within a lambda. This makes lambdas more consistent with regular methods and local functions. In C#, a ref read-only parameter allows a method, or lambda, to read a parameter by reference without modifying it. In ref read-only, ref right-pointing arrow passes by reference, can modify the original. Read-only right-pointing arrow prevents modification inside the method. Ref read-only right-pointing arrow passes by reference for performance, avoids copying large structs, but guarantees read-only access. Alias any type is a new feature in C# 12 that allows you to define an alias for any type, not just complex types, using the using keyword, even for primitive types like int, string, tuples, generic types, array types, pointer types, unsafe code. Types, methods, or assemblies can be marked with the system, diagnostics, code analysis, experimental attribute to indicate an experimental feature. The compiler issues a warning if you access a method or type annotated with the experimental attribute. C# 13.0 was launched in November 2024 with Visual Studio 2022 version 17.10 or later Visual Studio 2025 preview and .NET 9.0. Some important features of C# 13.0 are discussed in the next slides. In C#, params is a keyword used in method parameter to indicate that a method can accept a different number of parameters of the same type. This feature is often used when you want to create methods that can accept an undecided number of parameters. The lock class can be used to define regions of code that require mutually exclusive access between threads of a process, commonly called critical sections, to prevent concurrent accesses to a resource. A lock can be entered and exited, where the region of code between the enter and exit is a critical section associated with the lock. In C# 13, a new escape sequence, E, was introduced to represent the ASCII escape character, code 27 or 0 by 1b, commonly used in terminal control sequences, like ANSI escape codes for colored console output. In C# 13, there were small optimizations to overload resolution involving method groups, which made method group conversions more precise and consistent when used in ambiguous overload scenarios. In C# 13, you can now use implicit indexer access with the caret from end operator inside object initializer expressions. Previously, this wasn't allowed and would cause a compiler error. This change allows you to set values using indexers, including caret indices, directly in an object initializer, making object construction more concise and expressive. Before C# 13, trying to use ref locals or unsafe code inside an async or iterator method would cause a compiler error, because of potential lifetime and state machine safety issues. C# 12 adds language and compiler support to allow this safely in more scenarios. In C# 13, ref struct types are allowed to implement interfaces, which was not allowed in earlier versions. This is useful when you want to use stack-only types, like span less than t greater than, ref struct, etc., with polymorphism or generics constrained to an interface. In C# 13, the restriction that ref struct types cannot be used as type arguments for generics has been relaxed, as long as the generic method or type is not storing the value, and the usage avoids boxing, heap allocation, or capturing. In C# 13, you can now define partial properties and partial indexers in partial types. This allows you to split the implementation of a property or indexer across multiple parts of a partial class or struct, just like methods. Thank you. This is end of C# history part 3.